Miscellaneous exercise, very important exercise. Okay, see first question. First problem is prove that 2 cos pi by 13 cos 9 pi by 13 cos 3 pi by 13 plus cos 5 pi by 13 equals to 0. Proving part. Take left hand side and prove 0. Take left hand side. 2 cos pi by 13 cos 9 pi by 13 plus cos 3 pi by 13 plus only 13 only cos 3 pi by 13 plus cos 5 pi by 13. Okay, and right hand side is 0. You should prove this is 0. How to prove? Okay, if you see whatever till now I have given you formulae, okay, here you can apply these two terms, last two terms, cos c plus cos d. You can apply cos c plus cos d, correct? So you can go with that, cos c plus cos d. What is cos c plus cos d? This as it is pi by 13, okay, cos 9 pi by 13. Okay. Here cos c plus cos d is that 2 cos c plus d by 2, 2 cos c plus d by 2, but c means 3 pi by 13, d means 5 pi by 13. So 3 pi by 13 plus 5 pi by 13 divided by 2 into cos c minus d. So c minus d means 3 pi by 13 minus 5 pi by 13 and divide by 2. Okay, simplify. 2 cos pi by 13 cos 9 pi by 13 plus 2 cos. After simplification, what is this quantity, bracket quantity? This after simplification, you tell when denominator is same, then no need to take LCM. Directly you can add. Whenever denominator is same, like 1 by 2 plus 3 by 2, so you do 1 plus 3 4 by 2. You can see denominator same, 13 13, correct? So it will be 3 pi by 13 5 pi by 13. So 3 pi 8 pi by 13 and upon 2 also. So 8 pi by 13 upon 2 4 pi by 13. It is 4 pi by 13. Okay, into cos. Here again denominator same, 13 13. So 3 pi minus 5 pi minus 2 pi minus 2 pi and upon 2 minus pi only, na? So it is minus pi by 13, correct? And cos minus theta is plus cos theta. Cos minus theta is plus cos theta, correct? So you can simply also write like this, only cos pi by 13, and you can tell the reason here, because cos minus theta is cos theta. Okay, cos eat that negative sign. Now observe, there are two terms. This is first term and this is the second term. What is common? Is there anything common? 2 common, and cos pi by 13 also common. Then remaining here cos 5 pi by 13 plus cos 4 pi by 13. But you want to prove 0 and you don't know all these values, pi by 13, how much cos pi by 13, don't know. But definitely there will be something so that you will get the answer. Again, are you not thinking we can apply cos c plus cos d? Once again, here also cos c plus cos d we can apply. 2, this as it is pi by 13. Here apply cos c plus cos d. 2 cos c plus d by 2. C plus d by 2. So 5 pi by 13 and 4 pi by 13. How much? It is 9, not 5. It is 9. Okay. This is 9. So 9 pi by 13, 4 pi by 13. 9 pi by 13 and 4 pi by 13. So it is 13 pi by 13, and 13 13 cancel, only pi, but upon 2 is there, na, upon 2, it means it will be cos pi by 2. So what is this? This is, firstly I will write like this, next step I will write directly upon 2, okay, into cos c minus d, so 9 minus 9 pi by 13 minus 4 pi by 13 divided by 2, okay. Now 2 cos pi by 13 as it is into 2 cos, this is pi by 2, okay. How pi by 2? Because 9 pi plus 4 pi, 13, 13 pi by 13 is only pi, and upon 2, so pi by 2. And cos pi by 2 value, what is the value of cos pi by 2? 9 minus 4, 5 pi by 26, because 13 into 2, 26. Tell me what is cos pi by 2 value? Pi by 2 means 90, cos 90, cos 90 value, हाँ देखो 1 0, for that also you need this much time, cos pi by 2 is 0, okay. Every student knows in the class 10th cos 90 is 0. So 2 cos pi by 13 into 2 into 0 into cos 5 pi by 26. Now what is the final answer? 0 in the multiplication, 0 into anything, 0. So final answer 0, and this is your right hand side, okay, as proved. Note, see question number 2, left hand side, sin 3x plus sin x into sin x plus cos 3 minus cos x into cos x, cos 3x plus cos x into cos x, and right hand side is 0, right hand side is 0. So look at this problem, what should be your first step, how to think? You can see you can apply sin c plus sin d, and there cos c minus cos d. So that thought process is required, you should understand by looking at the problem, okay. What should be first step? The first step is that you should apply sin c minus sin d rule, sin c plus sin d, cos c minus cos d. So apply sin c plus sin d here. What is sin c plus sin d? 2 sin c plus d by 2 into cos c minus d by 2, okay, and into sin x, extra sin x is there, okay. Then plus here cos c minus cos d. What is cos c minus cos d? 2 cos c minus cos d rule. देखो, if they don't know anything, 2 sin c plus d by 2 into sin d minus c by 2, d minus c, or if you want to write 3x minus x by 2, then here extra minus sign will come, okay. There are two forms, if c minus d then minus here, into extra cos x is there, simplify, 2 sin, this time after simplification 4x upon 2, 2x, and this x only, 2x upon 2x into sin x, plus into minus, minus 2 sin 2x sin x cos x. You want 0. Now what to do next? Okay, what common? Tell me. 2 sin 2x common, cos x not common, complete term is same, okay. This term, that term same, the complete term is same. Here 2 sin 2x, okay, cos x sin x, and this also 2 sin 2x cos x, you can write here cos x sin x. So actually all are common, it means actually both are same, Complete term is same. So cancel. So this term cancel with this term. So answer is 0. Okay, 0 is right hand side. Question number 3. Can you decide how can you solve? Okay. How will you solve this problem? Number 3. Write LHS. Okay. Cos x plus cos y whole square plus sin x minus sin y whole square plus sin x minus sin y whole square, and right hand side is 4 cos square x plus y upon 2. See which formula is applicable? Cos c plus cos d. Good. Cos c plus cos d. In the second bracket, sin c minus sin d. So cos c plus cos d. Without formula, you can't survive in trigonometry. Formula are the most important. Cos c plus cos d, 2 cos c plus d by 2 into cos c minus d by 2. You have applied only formula, but again bracket whole square. So bracket whole square, outside bracket and whole square, plus here sin c minus sin d, 2 cos c plus d by 2 into sin c minus d by 2, but whole square. So whole square, open the whole square, 2 square 4 cos square x plus y upon 2, and here cos square x minus y upon 2. Similarly this bracket, 2 square 4 cos square x plus y by 2 and sin square x minus y upon 2. What next? 4 common and cos square x plus y upon 2 common, bracket cos square x minus y by 2 plus sin square. What next? 4 cos square x plus y upon 2, and this cos square theta plus sin square theta is always 1 if angle same, into 1 into 1. So 4 cos square x plus y upon 2, this is your right hand side, hence proved.